It's the AST, or the Alternating Series Test. So I like to abbreviate AST. And there's two parts to the alternating series test. So in general, if you have some alternating series like this, nice generic series, there's two things you need to show. One is the limit as n goes to infinity of an is equal to 0. And then the other one is that it is decreasing. So an plus 1 is smaller than an. Technically, it could equal. The reason they can equal is because if it's alternating and they were equal, and if one of them was a 3 and the other one was a negative 3, when you consider that negative sign part, well, when you add them together, that's 0, so it would help the series converge. Okay, so there's basically two things we need to show. One is that the limit equals 0. So we just need to use this sign part, so that just the an part, take the limit, I'm doing part 1, as n goes to infinity of sine, and then pi over n. And if the n is going to infinity, that means that here in the parentheses, we're getting pi divided by infinity, which becomes so small that it goes to 0. Which means that we get sine of 0, also known as sino. And sine of 0 is equal to 0, so it passes the first part of the alternating series test. The next thing to do is show that it's decreasing. So basically, if you have an an here and an an plus 1 is the next term, then it needs to be going down or decreasing. So you can do that, you can try to do that directly. So is sine pi and then have an n plus 1 in it, is that one actually smaller than when there is just an n? So it seems like, wow, how are you going to get like a trig identity for sine of pi over n plus 1? Well, you could use sine inverse on both sides, and if you use sine inverse on both sides, the signs disappear, and we just get pi over n plus 1 is smaller than pi over n. And then to finish up the algebra, you could divide both sides by pi, eliminating the pi, which I usually do for breakfast, eliminate the pi. And then you could invert, and when you invert, you also need to invert the inequality. So invert each fraction. And then, is n plus 1 bigger than n? Yes, it is. Or you could subtract n from both sides, and it says, is 1 bigger than 0? And oh, happy day, it is. So that means that it passed the second part of the alternating series test, and that means that it converges. And for those of you sticking around for the second part of the show, I'm going to show you, in case this algebra way doesn't work out, there is another way to do it. And that goes like this. So you go back to my graph, this fancy graph that I just drew right here. And if the function is going down, that means that the slope is negative. If the slope is negative, that means the derivative is negative. So can we show that the derivative is negative? So we have the function sine of pi over n. And so with this, I'm not using the n plus 1 and the n. I'm just saying, is this function going down? Is its derivative negative? So if this is the function, then take the derivative. From what I remember, the derivative of sine is cosine, and then n is our variable. And then there's the old chain rule, which says you have to take the derivative of pi over n. Well, the pi can just stay there, and the derivative of over n is going to be negative 1 over n squared. So, is that negative? Well, this part is definitely negative, because on top you have a negative, on the bottom you have a square, and a square is always positive. So that purple blob is a negative divided by a positive. That's definitely negative. And then what's happening with this cosine thing? Well, again, you could take the limit as n goes to infinity, and this part is becoming cosine of 0. It's not quite there, but it's almost cosine of 0. And cosine of 0 is equal to 1. So that means that we basically have the cosine part becoming a positive 1. This part is a negative, and that means that its derivative is negative, and therefore it's decreasing. And that is the end of today's podcast.